técnica. Podemos começar ou não? O povo lá de cima, aqui, ó, da técnica. Não vai bater a plaquete? Não? So, good morning, everyone. Thanks for coming. It's a pleasure for Environmental Studies Center to receive everyone here for this first workshop on laser application in stable water isotopes. This is for me, especially for me, it's a very important event because it's when we start to have our lab, despite the equipment is not here, but it's not neither my fault, neither Sense or Picavo fault. It's a problem with the customers in São Paulo that is blocking everything there. And for the opening roundtable, I would like to invite myself. I need to present. My name is Jim Gassmans. I'm a geologist. I'm a coordinator of the Laboratório de Recursos Hídricos e Isótopos Ambientais. Also, I'm in the final of my term as a postgraduate graduate program here in the IGCE, Geoscience and Environmental program. So, I would like to invite Antônio Celso Jardim from Sense. Antônio Celso Jardim is an electronics engineer who graduated a long time ago, and he has worked at Sense, representações comerciais for over 30 years. So, you graduate exactly at the same time. I'm 88. Throughout his career, he has held positions such as service engineer, product and application manager, and he's currently the company's business development director and partner. He has extensive experience in analytical instrumentation in general, especially mass spectrometry, which is specialization in magnetic sector mass spectrometry, and X-Spirit barrels. Thanks. I would like especially thanks Antônio Celso for this opportunity. Support us in this event. I also would like to invite Fernando Teixeira. Fernando is here. Graduated in agronomic engineering at UFSCar, so the must from St. Carlos, nearby, the big Ibaté city. He has specialized in stable isotopes and organic and inorganic elemental analysis. He currently works as business and application manager at Sense Representações Comerciais, supporting the whole Brazil and Latin America with focus on application support in the areas of stable isotopes applied to environmental sites. Thanks, Fernando. So we invited also Professor Amauri, but he was able to come to represent the SEA, and I will do his part. So I also would like to invite Kate Martin from Picavo. Kate is the Associate Sales Director at Picavo. She holds a Bachelor in French, German, and International Business, and has a 25-year story of technical sales, of which less than 15 were in a semiconductor world. Originally from England, Kate lived in France. I discovered he's very good French. That's fine. For many years, and he is a polyglot. Thank you for coming. a lot to share. They're more than so Celso, please. Whatever you want. Sim, pode falar em português.
Bom dia, pessoal. Mais uma vez é um prazer estar aqui na Unesp. Nós nos encontramos aqui algumas vezes, né, vários eventos. É legal voltar para cá. E agradecer à universidade pelo apoio dado ao workshop, ao professor Olivier, empenho, sempre, e ao CEA, que nos deu toda a infraestrutura. Eu espero que vocês aproveitem o evento de hoje, né? Teremos boas palestras, vai ser bem interessante esse dia de hoje para vocês, tá bom? Muito obrigado e bem-vindos.
Eu vou falar em português. Agradeço a oportunidade, o empenho do DJ. Em 2 semanas, a gente conseguiu organizar o workshop, principalmente a comissão organizadora, que em 2 semanas conseguiu reunir mais de 120 pessoas nessa primeira ideia de workshop, focada em isótopos estáveis usando laser. Então, é um começo e espero que vire uma tradição aí todos os anos, ou quem sabe, ano sim, ano não. E espero que todos aproveitem o evento. Acho que vai ser uma imersão bem bacana no assunto.
Bom dia, meu nome é Kate Martin. Não falo português, sorry, desculpe. But thank you very much for inviting me to represent my company, Picaro, here and talk about our ISO water system that is almost here. Almost here. And we'll give you some great examples of applications that you might be able to take to your research. And thank you. It's amazing to see so many people in such a short time. But great work. Look forward to discussing with you. Obrigada.
Bom, em nome do CEA, eu gostaria de agradecer a presença de todos. Eu acho que esse é um espaço que está à disposição. Vários eventos da Unesp aqui do campus de Rio Claro são realizados aqui nesse anfiteatro. É um lugar pequeno, mas é bem acolhedor. E é sempre bom ver ele cheio. Eu gostaria também de agradecer especialmente as meninas que trabalharam nesses dias todos para organizar isso. Foi uma decisão de 2 semanas. Em 2 semanas, a Rafa, a Natália, a Ana, a Gene e a Carol, que não pôde vir porque tinha uma viagem marcada, realizaram um trabalho sensacional de organizar tudo, providenciar os copinhos, providenciar a transmissão pela internet, fazer os convites. Isso eu acho que está todo mundo de parabéns, eu gostaria de agradecer especialmente. E eu gostaria também de agradecer a SENS por todo o suporte dado para a realização do evento. A ideia foi do Fernando e a Picaro também, obviamente. Eles são os parceiros comerciais. E também durante todo o processo de aquisição e as burocracias que tiveram que ser vencidas nesse tempo, o suporte do Celso. Estamos esperando o equipamento por mais breve possível. Eu considero que esse é um evento não vai ter uma plaquinha, mas é um evento de inauguração do laboratório, que está, depois de 15 anos, tomando uma forma, e eu acho que isso pessoalmente, é uma coisa bastante importante. E, bom, eu acho que era isso para essa cerimônia de abertura. Eu vou apresentar um pouco o contexto científico no qual esse equipamento foi adquirido agora, que é o projeto Isotope. E gostaria de agradecer a presença de todos. Depois a gente continua com a nossa programação. Muito obrigado. Thank you. Teve um tremor de terra. É um pequeno tremor, né? É. So, we decided to make our presentation in English because of the presence of Kate. Yeah, it's better to understand. Someone probably will speak in Portuguese, but this workshop and the equipment is in the umbrella, under the umbrella of Isotope, tracking urban water pathways using water-stable isotopes. So this is a research project. Basically, it's a CPhydro from FINAP. We got the money from FINAP. And this money also is interveniencia by Fundunas. So we have two problems, one in the national way and the second one in the structure of UNESCO. But what is basically the idea of this project is to better understand the modifications that the urbanizations put on the water pathways. So when we have almost pristine environment, the water floods have very well no. We have the precipitation, then we have the evaporation and transpiration controlled by soil and the vegetation. We have the infiltration that recharge aquifers, and this recharge produces some base flow that feeds the rivers by and produce the runoff. Also, we have the runoff of the water, the excess of water over the surface. But when the cities and the urbanization installed over these areas, we have a lot of soil impermeabilization and also vegetation suppression. So if we have vegetation suppression, we can expect a modification in transpiration, and due to soil impermeabilization, we may have some reducing on infiltration rates. So this is important to observe looking in this picture. The changes in flow magnitudes. The arrows, the size of the arrows indicate the flow magnitudes. The only thing that in principle stay the same is the precipitation. Not true, because we are looking some kind of heat cells in the city that can produce more precipitation. So we reduce evaporation, we reduce a lot of infiltration, and we install an underground system of water distribution, water and sewage distribution that makes some influence on the infiltration and produce some changes on the base flow that arrives at the rivers, because we are putting other water than, instead of have only precipitation, we may have groundwater or surface water. In some cases in the northern hemisphere, we may have some glaciers water, the melts produce water to feed the cities. And this changes the composition, chemical, and the isotopic composition of this final reservoir of water in the cities. Something that is very, we don't have too much studies about that, but it's the impacts on vegetation. There is a question: what is the water that the urban vegetation takes? Is the water from the precipitation? Is the water from our water system supply? This is something very little studied. Also, one of the important changes produced by the cities and by the urbanization is the urban water supply system. So everyone that lives in the city is need water to survive. and this water can be supplied from public service or private companies. Now we are discussing this movement from a public company here in Rio Claro for a private company. Actually, I have my opinion, but I prefer don't give it. But it produced a complex system of water distribution based on multiple sources. So, for example, here in Rio Claro, we have part of the city supplied by two rivers, Ribeirão Claro and Rio Corumbacaí, and also some parts of the city, like Assistência, supplied by water watch. We have other cities like Ribeirão Preto, that is 100% supplied by groundwater. My city, Araraquara, is supplied about 60% of groundwater and 40% of surface water, and there is a political movement to move for 100% supplied by groundwater. It's a good thing? Probably not, but it's a decision. So these changes or this supply, this multiple source supply, has a direct impact on groundwater and base flow, the base flow generation, and also the base flow origin, and also the eco-hydrological impacts that I mentioned in the previous slide. Under this complex context of water in the cities, the urban water cycle, we did a previous study. It's a master thesis from the program. Vanderlei Lances, he finished on 2021 or 22. This paper was published in 22. And we did a comparison between urban and pristine catchments. This study was done in Sorocaba. And close to Sorocaba, we have the Floresta Nacional de Ipanema. It's a very nice spot. I recommend to visit there. There are some history and some natural landscape. These two catchment has different geological framework. In the urban area is a fractured aquifer, and in the pristine catchment is a sedimentary basin. So this is some impacts on groundwater storage and circulation that reflect on the isotopic composition of groundwater. And we found that the urban catchment, due to the introduction of pipelines that produce some kind of leakage, we have a contribution of this leakage on the base flow of the river in this catchment. Based on that, we calculated the contribution from groundwater and precipitation in this area, and we discovered that most of the water that flows in the river comes from groundwater discharge. Instead of in the urban area, we have an important, about 35% of the contribution for discharging the river come from the leakage of the water supply system. So with this framework, we asked for FINEP, and we proposed this project, Isotrack, tracking urban water pathways using water-stable isotopes, in a public call, CTIGRO, in 2022. The principal, we were not selected to have the funds, and then 6 months later, we received the positive feedback from FINEP, and we got the money. And the proposal basically is to track water pathways in urban areas by the characterization of isotopic composition of multiple water supply sources. And the idea is to improve the knowledge in many cities. So we decided to do the first study area in Araraquara because I'm from there, and also because it's the most beautiful city of this São Paulo state, and has the best football team in São Paulo state too. So if you don't know Araraquara, you may go there. Basically, it's to improve the knowledge how the water is participating in this complex eco-hydrological system. Also, we have two goals that is contribute something for the urban planning. So by the inclusion of isotopic techniques in the urban planning. We can do that. I don't know. I have to convince the managers and the plannings to get this information as an important information to organize the space in the cities. So Araraquara, this is a view, an aerial view from Araraquara. Araraquara is located close to Rio Claro, is in the middle of the state. Has about 250,000 inhabitants. All the cities, all the citizens are supplied by a public service of water, and it's based on groundwater, Guarani aquifer system, and 3 rivers that complements this system. Also, we have a lot of wells drilled in 2 other aquifers that were used for complement or for private uses of water. So we did at that time 1 field campaign. We have the results, but we have not time to discuss it. We took 73 tap waters samples, 4 waters that come from these treatment plants that supply the water, 28 samples in the rivers, and 36 wells in the around the city. So the first result, we have produced an interactive map. Thanks to Vinicius. Vinicius is not here, but he did a very good job with dealing with this map. And this map, we have the differentiation of the samples, as well a variation on isotopic composition. Is an interactive map, very good for these purposes. E agora? So the preliminary results, we did some maps, but I won't show you these maps, but we can see that the river, we collect the samples in at the end of this last year, so it's in rainy season. It's very close to the rainfall weighted average. We have 10 years of observation of rain in Araraquara, but the tap water is divided in part of the water comes from these wells are in blues, and part of the water is related to the water treatment plants and the rivers, more enriched than the part of the cities that is supplied by groundwater. We have to discuss a little bit more about that and look at careful in these results, but this is the preliminary results. Some take-home lessons and future perspectives for this project. Water stable isotopes were able to track multiple sources for stable tap water because the isotopic signature is completely different. We need to install, or we need to start a continuous monitoring, so to have an idea about changes on hydrological cycle and changes on sources for tap water. We need continuous monitoring to evaluate seasonal variability, especially on surface water and the forwards connections, and seasonal changes in water supply network. So this is something that can be used for small urban catchment students. So we can choose a small catchment and do something more focused on this catchment. And something that I hope to implement close is this kind of this proposal of eco-hydrological perspective, biosphere in the cities. So this is our small team. I forget to put Felipe, sorry for that. But Vinicius is a postdoc student. Now he's teaching in Ourinhos. Right? Gabriel Siqueira is a geology undergrad student. Jennifer also is over there. She's here. So she is helping us with this project. And if someone is interested on join us in this project, please let me know. Thank you. We have time for questions. So. I asked it for the organizing committee if you have. Do you want to make a question, Robert?
Yeah, very quick one.
Okay.
How far are you prepared for dealing with smaller temporal scales, high frequency sampling? So since you just got a very nice equipment from Picaro, so are you
Not yet.
Not yet. About
It's a virtual one.
about to get one, but how are you already thinking in having this kind of devices? Because this is something that few people here in Brazil and Latin America they do have and work on that temporal scale.
Yeah, good question. This is one of the ideas is to have a kind of small catchment to study in the city. And we have the equipment to take samples. We have a ISCO sampling device to have this kind of sample in high frequency. It's easy because it's close to my home, but I guess Selena will be able to explain a little bit more about this high frequency and the influence of thunderstorms on surface water. But the idea is to have this kind of study. So, but we need anyway. We need to have the equipment installed.
Quick question.
Yeah.
Do you pretend to expand the cities or the cities around? Because I know that Araraquara you have a very little rain. So do you intend to use this around? Or because I am from Mato.
Yeah, I know.
There's you have very, very little rain, but then would have more chance for that to expand.
Yeah. It depends on the conditions. So to do anything in research, I need studies. This is something that and to create more study areas or to expand the area, we need to have more students involved on that. We decided to start with Araraquara for obvious reasons. And the idea is to do something here in Rio Claro, especially related to this eco-hydrological perspective, because we have Porto here, and we have a very complex soil system in this area. And also we have a big square in the center of the city. That is very nice spot and do this kind of comparison. So it's difficult to say yes or no. There is a possibility there. There is a possibility.
Go to the next one.
So it seems that I will be the a Laura quer ir? Não, a Laura não chegou, né?
Agora foi, né?
Então, não, é a Laura. Sim. Presidente, olha só.
Não fez no horário, certo?
Mas era para ser ela. E aí?
O Fernando vai apresentar?
Não.
Celso?
O Celso, mas e a Kate? Ah, Kate. Ó, sorry. So I would like to invite Kate to give us an overview about Picaro and isotopic applications on laser isotopic applications. Thank you for coming.
Is the second one? Yes. Isn't this format? Is PDF? Yeah. Okay, so it's good like this. Okay. Yes, and this one is yeah. Oh, actually, it's a PDF, so we will need to move like this. You can tell me, and I can move to you. Okay, it's okay. That's better. And if you need to point, I think is here. Yeah. Okay, great.
Acho que você clicar ali na direita e liga no slide.
Oi?
Clicar ali na direita embaixo e liga no slide.
Thank you. Okay, I have a brief presentation. Thank you very much for inviting me to talk about the instruments that Professor Gasmans has just bought. Unfortunately, it's stuck in customs, I hear, but it'll be here soon. It's almost here. So Picaro is an American company. We're based just outside San Francisco in California. And our technology came out of the University of Stanford. We have several patents that come from Stanford itself, and then also many patents that Picaro has been producing over the years to improve our technology and make it one of the most precise and most easy instruments to use on the market. We have over 320 employees to date. We're growing very fast. I joined the company 5.5 years ago, and we were only 100. So now we're over 300, even increasing during COVID. And of those 320 people, there are more than 35 who are all PhDs. So we have many scientists inside the company helping develop our products. So let me tell you a little bit about the technology that's inside the Picaro. What we do is we have a small cavity. It's only about this big, a lot smaller than other solutions. There are 3 mirrors inside the cavity, and the laser is going to send the light inside, and it bounces off the 3 mirrors until the light goes away. This is what we mean by cavity ring-down spectroscopy. If you think of a bell, when it dings, that noise goes. And the light technology is doing the same thing. When you're in a cavity that's empty with no gas, it takes quite a long time for that light to disappear. When you add a gas, each gas has its own fingerprint of how long it takes to disappear. So we create a graph on that. Our cavity is only 35 cc in size. However, the distance of the light bouncing off the three mirrors is over 10 kilometers, in some cases up to 20 kilometers. So it's a time measurement, not a light-based measurement, and this helps us to be much more precise. What does a Picaro look like? Well, if you remember the old CPUs that old folk like me and my colleagues here, similar age, we have those big, heavy CPUs in our offices. That's pretty much the size of a Picaro, about 19-inch. From the top, we have our technology. Here is the cavity inside what we call the hot box. And the warm box here has our wavelength monitor. If you turn it upside down, it's just a computer system. So we're providing our solutions on Windows 10, Windows 11 coming soon, and there are some instruments that have Linux. Ultimately, everything will move to Linux so that we don't have to keep upgrading for the Windows updates. And from the back, it's quite simple. You have your regular computer interfaces, data output, VGA, etc. And this is where the gas is going to go in. The inlet is at the top, and then we will connect a vacuum pump on the outlet to draw the air inside the computer, inside the analyzer. So why do people choose a Picaro and not something else? Firstly, it's probably the most simplest solution you're going to find on the market. I'm told even dogs can use it. I need that picture with you. So basically, once you've turned the pump on, turn the instrument on, leave it maybe 20, 30 minutes to warm up. It's ready to sample straight away. We can do up to 900 injections per day, depending on the mode that you're going to use with our instrument. It's extremely precise, the most precise solution on the market. It's also expandable. We're going to look at different peripherals that you can add to the basic setup during my presentation. It has very minimal maintenance. You change your filter once every 1 or 2 years, depending how dusty your air is. You change your computer fans and the diaphragm on the pump. That's it. No cleaning of mirrors, no having to send it to the factory to be calibrated. It's very simple. And for service and support, not only do we have online support with the technicians in the USA, but we have our partners here in Brazil, Sense, who are technically trained to help you with your implementation, but also maintaining the product throughout the year so it will have a long life. So we're going to look at the system itself. This is what you'll be able to see very soon. So the box we have, a bit like the old CPU, an auto sampler, and a vaporizer. This is the essential setup for any liquid water measurements. We only have two versions. The version that's coming here is doing 18.0 and deuterium. And then we have also the 2140 that has 17.0 as well. So this is the solution that people choose just in case they want 17.0. If you don't need that, then the 2130. And here we take a look at the different peripherals. In my presentation, we're going to look at some different examples of which ones to use. This, for example, here is our micro-combustion module. If you're going to have liquid water that has high content in organics and you prefer not to pre-filter, then this sits on the back outside here and it will burn away the carbon and then give off the gas inside the Picaro. If you want a solution for measuring water continuously, such as in a boat, or you're collecting from a stream, then we have our continuous water sampler. And in this case, it's going to replace the vaporized water sampler. We have our standards delivery module. if you are taking vapor measurements out in the field and it's too complicated to take your standards with you, then you can use this as a simple way to switch between the vapor measurements you're making and then the standards that you're going to do before and after your samples. And then finally, if you have samples that are coming from plants, twigs, leaves, maybe even soils, you have our induction module, which is similar to the previous one here, in that it's going to combust the carbon away and the water gas is going to, the vapor is going to go into the percolum. So first of all, before we get into some client examples, we have a slide about our new different modes of percolum that can increase the amount of samples that you can do per day. One of the problems that you find with isotope measurements is from one sample to another, you can leave memory. So we've developed a new method, our express mode, that has a quick way to flush through the system with the sample that you're going to sample. That way, the memory that is in there is the memory from the sample, so it's not going to interfere from one sample to another. And then we also have our survey mode. And in this case, if you have a lot of unidentified samples, you have no idea where these are from. For example, people are sending them to you to be measured, and they have no data already. You can use a survey mode to quickly measure everything. And then you can reorganize your samples from the lowest to the highest. It makes things a lot simpler. And of course, the standard mode that everyone's been using for the last few years. So we just wanted to show the express mode, which is probably the most popular mode right now, how it works. This is the way of the past. You would put your sample in and have a whole bunch of samples, 3 for example, that you're completely going to throw away. And then you would have your regular sample stage, and then again, the red side, memory, flush. What we're doing with the express mode is taking the sample that you want to measure and creating 6 very rapid injections. So flushing out everything that was there before. And then we can move on to the regular sampling. So you can see in comparison, it's almost twice as quick as the previous methods, and means that you can do a lot more measurements in the day. So now let's look at some examples of measurements that you can do. This one here, for example, is eddy covariance. We're going to have a tower here. This example, I think, is from the USDA, 2.5 meters in height, and has different levels of measurement from soil level up to the top of the canopy of, in this case, corn plants. And it's connected via a manifold into the Picaro. If you're going to use Picaro outdoors, obviously you don't want to take a zero air canister into the field, so you can use dry rise to dry the sample before it comes into Picaro. So here's the actual example from USDA in Louisiana in human. They have our 2140 and the auto sample vapor is obviously connected via the manifold as we saw in the previous demonstration. And they're doing quite a lot of different types of measurements. They're measuring the rain, obviously, but also taking groundwater samples and then doing the different measurements of the different heights of the canopy to check on the improvements they're making into the plants and its impact on transpiration. Next example is our continuous water sampler. And this is becoming more and more popular, used by many different researchers in different areas. As we're short on time, I'm just going to give a couple of examples, but if you have an interest in this product, we can show you some of the different researchers' work. So basically, inside here, we're going to collect the water as we're moving on the river, or collecting the water from the stream. It comes into the bag and is combusted. Actually, first of all, the water is filtered. There's a membrane for collecting, removing the organics and seawater, salts, for example. Then it's combusted, and the sample is then sent inside the Picaro. An exciting example that has come up over the last couple of years is in China from their version of CEA. They're using the water table to try and predict when an earthquake is going to happen. So they have seen that there are changes in the water composition right before an earthquake is happening. So originally they were taking discrete samples and bringing it back to the lab and running it on the autosite vaporizer. But now in 2 different locations in China, they have installed continuous water so that they can be measuring this live and following the reactions. So we're very interested to see the papers that come out of this research because it could be extremely helpful. Another example close to where I live is on the Sacramento River Delta. So this is a large river in California that goes out into the San Francisco Bay. So it's a tidal river at the base. The tidal waters are infiltrating the river, but it's also a river that has over 100 tributaries. And the USGS are using the continuous water sample to track where that water is coming from, whether it's coming from the streams, whether it's rain even from Hawaii. We have a rain weather pattern we call the Pineapple Express. Brings rain all the way from Hawaii into California, up into the mountains and beyond. And you can track where everything came from with the continuous water sample. The next equipment that we want to talk about, so these are small consumables, are what makes Picaro a little different from other solutions on the market. There are instruments that have a hard time with water that has salt content. And so we designed these very small, simple salt liners that you could put inside the vaporizer. And with that, you can measure seawater directly. You can measure urine, for example, if you're doing some health products. And there's no problem with these salts getting inside the vaporizer and contaminating the instrument in the end. So together with the vaporizer cleaning kit, these are great solutions for samples that are high in salt content. Recent example here in Latin America, just 2 months ago, we went to El Salvador to install their instrument. They are measuring waters from all over the country, including seawaters. So they're going to find the salt liners very, very useful. This is a view from their office. It's, as you can see, quite beautiful. And we have here 2 different volcanoes. So they're going to be pre-filtering their samples before they go into the Picaro. Another type of application that we wanted to show you of consumable product is our dual mode kit, which means that you can quickly change between vapor and liquid water measurements. So it's a hardware connection that sits on the back, and then you would connect your standards from one side. So it depends on what type of application you want to do, but the most common usage is for in-lab sampling for the between the vapor samples you want to measure and the standards. The example we want to show here is from Utah. They have 6 different Picaros or Lysa water systems that they've collected over the years. One where they use the standards delivery module is on the top of a mountain, a ski station. It's actually in the building that runs the ski lifts. So it's a part of the mountain that is inaccessible at certain times of the year due to the weather. So they're able to install their vapor analyzer there with the SDM and run that automatically. And it can take up to 3-4 weeks of standards there, so they don't need to go over time. They have many different use cases. There's, for example, forensics work they're doing, mapping rivers from all over the world to help with repatriation of fallen soldiers. And then they do like to show off their rover. So it's IsoWater rover. Basically, the Picaro is in a truck, and they take that to measure wherever they want. And we mentioned with the salt liners, a typical application is measuring urine. This example here is one of several. Most companies don't let us talk about them, but on your marks is one that is allowed. So watch out, because next Olympics, I think the Swiss team is going to be really good. They are testing their athletes, giving them different products, and using their urine to measure how the influence of the products that they're giving to them. So their performance should be enhanced if everything goes well. And then one of my favorite topics, we have several Picaros that go back and forth to both of the poles. In this case, we're highlighting the project Deep Ice, which is a European-funded set of studies where there's 11 different organizations that are helping institutes mostly in Europe train new students. So Picard is one of the companies there, and we'd like to throw that idea out to all of you here, is if you create similar studies, each year the organizations come and train the new scientists in how to use the instruments that they'll need for their research. If you get a copy of the presentation later and go to this link, you'll see our scientist, Magdalena from the European team, who's giving some training at this precise moment. And a completely different use case here for you is a study center in Austria where they are trying to improve truck engines so that they emit less. And so basically they have a big combustion part to their system. This is similar to the engine. And then they're taking the gas through a catalyzer so that they're reducing the humidity and getting rid of any impurities, and then taking it to the Picard for the water measurements. And then one, almost to the end, example here in China. We have several examples in the US too, but I'm not allowed to talk about the names. This is an example here from Wuji in China, where the companies that are mining or fracking oil and gas extraction are using the waters to predict when there's going to be the pumping of the oil. Or in the case we have up here, this example is from Colorado, where they have a big regulations on oil and gas pollution getting into the water table. And they have to pay fines per day for that pollution. So they have to show very quickly that this pollution has gone after they've made their modifications. That's an example from a Colorado company and a similar situation in Texas. And thank you very much. And if you have any questions, please let me know.
I think it's better to give them. Let me try this.
Thanks, Kate. Thanks. Thanks. Obrigado for this nice talk. I would like to know what is the difference between the system that is able to measure only the double pair, oxygen 18 and 16, and the triple oxygen. What is basically the difference between the measurement system?
It's very simple. There's one extra laser that will measure specifically the 70. So otherwise, it's exactly the same.
The same. You have only one more laser.
Yeah.
And it is possible to add this laser in the double oxygen system or not?
Unfortunately not. But
It's
if you
possible.
want to trade in, we can also come to agreement.
And so this is interesting because the multiple possibilities of application of water stable isotopes is very interesting. So this is something that we are only used to determine, okay, this water is coming from rain or not, but we have other possibilities that we can develop here in Brazil. Thanks for
Yes,
your
exactly.
talk.
Thank you.
Thanks. Thanks. No, let's go without it. No, it's okay. The portability of the equipment, how portable it is. You mentioned that you can get a Picaro on a boat. You mentioned that you get a Picaro on the field. How realistic it is that they really work so well in very hard and tropical conditions. This is something that we would like to know.
So obviously, the Picaro is a computer, so there are some precautions that you will need to make. We don't like to sit out in the sun. I'm going to go back a few slides on here, show you the Gabe at Utah. You see here he has an umbrella to keep it protected. This is how they get their instrument out. It is a computer, so it's about 50 pounds. Not something you want to have on your back. But so long as you keep the operating temperature within below 40 degrees Celsius, it's okay. No direct sunlight. And if you are going to take it in the field, then we recommend you change the particulate filter more often than if you were going to leave it in the lab.
The whole treatment is under the umbrella.
Yeah. Yeah. So it's about 19 inches. Not much bigger than that.
Sorry if I didn't say the market is my question is for example, control parameter when you need maintenance machine. For example, when you take the sample freshly, total solid dissolved, yes, the matching, where is the thing the maintenance or clear matching? For example, when you take a sample, yes, you collect a sample. The sample is very arrangement for the conductivity or total solid total solid. Yes. What is the control parameter for the clear machine?
So your question is
The flushing system
the
for high
flushing
conductivity.
system, or if you have some kind of control in the machine to see if the water is
Yes.
okay. Yes, you want to know if the Picaro has a system that control the TDS of the sample. Just say, okay, we need to clean the sample or not.
So yes, we do have a software called ChemCorrect, and if your sample is outside of the measurement range, it will tell you. It will have this one is maybe okay, this one is definitely not okay. In this case, then you can rerun the sample after filtering, or maybe use the MCM, the microcombustion module. So yes, we do include software that can tell you that.
So it's a kind of warning about.
Yeah, so warning system. Yeah.
What is the limit of salinity that you can inject the water without any preparation for removal?
That's a great question, and I don't recall the percentage, but seawater is fine, but I can get back to you.
But seawater, if you have this system to remove the salt.
Yeah, it's better to use the salt liners, yes.
Okay. But for natural waters, for example, if you have, I don't know, 100 ppm of salt is okay.
I think so, yeah. And I will definitely get you the precise answer from my scientists.
Can I make a comment? The
Not
larger
yet.
concern in Brazil is bias of, it's a potential bias of such a, so like many others here. It makes a large and a big difference to have people in Brazil being responsible and capable of doing the maintenance of such countries. So sometimes when we have to decide between a higher price and a lower price, at the beginning we can be willing to go for the lower price option, but this on a long term, or even in a shorter term, it's not always the best way to go. I'm not talking about that Picasso is cheaper or expensive. I have no idea. I can only say that to have sense, for example, as a partner in Brazil, and working close to the buyers and being able to do a good maintenance and this service, that makes the whole difference, because anything can happen in Brazil related to the place where the equipment is being stored, or the room where the DA is going to find and his team, where the equipment is going to be. Sometimes the conditions are not the ideal ones. So, I mean, the whole story at the end, to summarize, it's good to have good partners in the country. And we are so happy that you are here today.
Yes, thank you. I totally agree. And since already Fernando's been trained for 2 years now, almost. And we have 2 more technicians, Eduardo somewhere over here, and Matthias. So they have the same training that my tech support team are trained in. So local in Portuguese, and as you say, eyes on the ground, so they know your setup. They know how to train you with the best preventative maintenance. There's nothing better. Thank you.
Hi. Just a comment. It's not just a problem with the isotopic world. After the world economic crisis, many of our suppliers closed the offices here, and we stuck without any support. And even when you import some new equipment, the technicians that are here, they are not able to solve our questions. Anyway, the golden question: how much it costs?
I will defer to
In
my reps.
very simple mode.
In simple mode, it's not the cheapest solution, but it's the easiest solution, and it's the solution that's going to last the longest. And if you'd like a price, then talk to my team here with them.
I will.
Obrigada.
So thanks for your nice talk.
Okay, this is good.
Embaixo, aqui embaixo. Não. Isso. Aí.
Laura?
Oi,
Bom dia. Se você quiser, pode compartilhar sua apresentação, tá bom?
bom dia.
Bom dia.
Sim, estou procurando a apresentação aqui.
Tudo bem, obrigada, viu?
Só um minuto que...
Deixa eu aumentar o volume. E aí o microfone vai ficar ligado, você vai deixar o áudio dela sair. Deixa eu fazer aqui. Isso. Vai ficar,
Está aparecendo?
Sim, está.
Não tá, não deve estar no formato apresentação, né?
Ainda não. Agora sim, está ótimo.
Agora tá?
Sim.
É,
Só um minutinho que eu vou chamar o Didier para te apresentar. Aí em seguida
tá.
você pode fazer a apresentação, tá bom? Obrigada. Agora sim, Didier, tá pegando áudio.
Bom dia, Laura.
Bom dia, Didier.
Bem, vamos. Deixa eu te achar aqui, que eu tenho que te apresentar. Muito obrigado pelo... Uma pena você não ter podido vir, mas muito obrigado por estar aqui com a gente. So, Professor Laura Simone Borna is a researcher at the INPE. She holds a degree in civil engineering from the universities of Ouro Preto, a master and PhD in civil engineering and environmental geotechnics from the Federal University of Rio de Janeiro. She has been a researcher at the INPE, Institute for Space Research, since 2009, working in eco-hydrology and soil physics, especially on soil-plant atmosphere interactions and the impacts of climate land use changes. She currently coordinates the graduate program at the end, I hope. You are in the final of your term. Graduate program in Earth System Science at INPE and leads the Eco-Hydrology Lab. She is also a member of the International Soil Modeling Consortium. Their research focuses on water and climate regulation service across Brazil and Bahia. Thanks, Laura, for accepting this invitation, and the floor is yours.
Oi, Laura, você
Thank you, Didier. And just a technical question. I listen in double. I don't know if it's only me or you. It happens with you also.
Eu acho que já está no máximo. Já. Você está escutando a gente, Laura?
Sim, mas duas vezes.
Oi?
Ah, duas vezes.
Eu
Acho que
escuto repetido.
Ah, tá. Tem que desligar um computador.
Mas eu acho que só tá com esse áudio. Mas o seu áudio está ok, Laura. Se você quiser, então, pode começar.
Pode.
Só se botar um pouquinho mais alto. A única coisa que a gente te pede é só para falar um pouquinho mais alto por conta do áudio da sala.
Okay. Good. So
Pode começar. Obrigada.
Okay, thank you, GGA and the SINS group to invite me for this workshop. And what I'm going to present here is the work what we are doing in the sorry, because I think I need to close my microphone because I listened myself with a delay, so it's a bit strange. On here,
Laura, só um minutinho, que a gente teve um problema técnico.
uhum.
Sabe o que a gente tinha que fazer?
Deixa o microfone aqui ou não?
Ver se o microfone melhorou.
Não sei. Fala alguma coisa, Laura.
Oi. Estão me ouvindo?
Sim.
Agora
É
sim.
estranho porque eu fico me ouvindo com um delay, então eu não consigo falar em cima de mim
Laura,
mesmo.
a gente. Aqui o seu áudio aparece normal. Eu não sei se é alguma coisa que está aí no seu computador.
Sim, não sei. Agora não, eu acho que agora eu estou ouvindo uma vez só.
Então agora está tudo bem. Então pode começar.
Então,
Obrigada, viu?
tá
Desculpa
bom.
mais uma vez.
Imagina. Ok, então a minha apresentação está na tela, não, né?
Está. O slide está aparecendo, tá?
Uhum. Well, again, so I would like to thank you, GGA and the SINS group to invite me for this workshop. It's very nice to see here in Brazil things like that happening. And then for us that work with isotopes, it's a real opportunity to change ideas and projects, and let's see the continuity of these talks. And what I'm going to present here is the work that we have been done in Paraíba do Sul River Basin in terms of ecohydrological studies and isotopic studies to complete ecohydrological interpretations of the functioning of tropical forests. The main focus of our study, our researchers, is the role of tropical forests in water regulation. Normally, it's common to take into account the ecosystem services of tropical forests, mainly related to carbon uptake or biodiversity preservation. But in terms of water regulation, I have to say that we still have some questions, scientific questions, and in relation how this forest can really improve the water production, mainly if you think in terms of reforestation activities, reforestation efforts, focused mainly on carbon uptake. Why this question emerges? Just a brief overview here about the trade-off, the process photosynthesis and evapotranspiration. Well, maybe it's, you already know, but when the photosynthesis it takes place by the stomata, and then in the moment that the stomata open to capture CO2, immediately plant releases water. The water that is liquid water transformed in vapor water. So inherent to the ability of the forest to uptake carbon, and in terms of ecosystem services, the ability of the forest to mitigate climate change. We also have transpiration, and which together evaporation, it's called evapotranspiration. And this part of the water, it is evapotranspiration, is part of the precipitation that is transformed in vapor. Well, it's good for the climate, it's good for rainfall production, it's good for cooling the temperature, but in terms of available water for discharge, drainage, and maybe groundwater reservoirs, it can be a kind of competition. So there is still some questions, mainly scientific questions, about the whole of this forest when we plant trees and the trees growing fast, how much water these trees will need. And in fact, this tree will compete with drainage and recharge. We still don't know. Mathematically, we tend to think that there is a competition, but it's interesting to see that global efforts of reforestation initiatives are taking place globally and in Amazonia. And curiously, if we talk with people that lives in the field, local people, and normally we listen, oh, okay, after the reforestation or after some preservation activity, we found more springs in our property. So in some cases, huge reforestation activities are related to decrease of the groundwater and river water sources, but in some activities, I don't know if it's a problem of scale, but in some activities, local people report increase of water availability. So it's a scientific question, and it's still open. And then we consider it important for scientific perspective and also for social and economic perspectives. So in this context, we created this Lab Eco, eco-hydrology laboratory, Isotope eco-hydrology laboratory at INPE. We created this laboratory in 2018, and it was moved by the Conexão Mata Atlântica project. It's a project for reforestation and payment for ecosystem services that was focused on Paraíba do Sul River Basin. And then this lab was supported by INPE, FINEP, FAPESP, CNPq, and is focused on understanding how native vegetation influences water availability. And then we also use stable water as isotopes as a research tool. This is an overview of our lab and our equipment. We also have a Picaro that was very well described by Katie, the model 2030i. And then we also have a cryogenic extractor because we also focus on water from trees and water from soil. So we need to work together with this cryogenic extractor. In our field scale, we have this, together with the Lab Eco, we have an experimental station located in São Francisco Xavier, which is a district of São José dos Campos municipality here in Paraíba do Sul River Basin in the Mantiqueira mountain. And then we have some equipments in this eco-hydrological station, such as meteorological station, lysimeter to measure infiltrated water. We also have soil moisture measurements, flow measurements, and eventually we also measure groundwater level. And eventually we measure true fall, stem fall, and to see if there is some variation in the isotopic signal, because we also are interested in to see the source of water transported by plants. And then this is an overview of the samples that we collect in this experimental station. So we collect true fall, stem fall, infiltration, soil water, subsurface water, stem flow, true flow, and rainfall we collect by events. And also we begin to collect monthly using the collector from DDA, which one of this collector is installed in São Francisco Xavier, in our experimental station. Another is installed in São José dos Campos. And then, so these are the scales that we work. We begin to work in this experimental station in a local scale, but we amplified our scale, working also in a larger area here in São Francisco Xavier, which is called Área de Proteção Ambiental, Environmental Protection Area of São Francisco Xavier. And then in this area, we collect river water in many points. We also expanded our collection for a transect that crossed the river, the Paraíba do Sul River Basin, and then we collect it links São Francisco Xavier, São José dos Campos municipality, the Serra do Mar mountain region close to the ocean, and the Pissinguaba nucleus also closer to the ocean. So it was a thesis, a PhD thesis of Kleber Assis, and then he collects rainfall samples, and also we also collect river samples and sometimes groundwater samples, just to complete our understanding of the behavior of the water recharge. More recently, we expanded our studies for the Mosaico Mantiqueira. This is a mosaic of conservation units along the Mantiqueira region. And then in these areas, we normally collect rainfall and river water, sometimes groundwater. And more recently, the study expanded a bit more with the studies from Luciana Ferreira and Cássia Almeida. Luciana is a postdoc. She is with you and right now, and Cássia Almeida is a PhD student. So Luciana is studying the isotopic signal of tip wells and springs in São José dos Campos. She will talk more about this soon. And Cássia is studying the tap water, and she collects samples in 2022 and 2023, but the thesis is still ongoing. Well, some results. Just a brief overview of some results, and then I chose here, for example, to compare isotopic signal of rainfall in São José dos Campos, isotopic signal of rainfall in São Francisco Xavier, the true fall, the transpiration, the trees, the xylem water in the trees, the soil. This is a column of soil of 2 meters depth. And then we also groundwater, lysimeter, river water in São Francisco Xavier, river water in São José dos Campos, and tap water in São José dos Campos. So it's a mix of some measurements of the studies, and then we are still analyzing these results. I'm open to discussion with colleagues, but what I can see a bit clear is that it's not very clear now, but when I compare these values, I saw that the main source, potentially the main source of water that feeds the tap water, the river, and the groundwater, and also the trees, is the rainy season water, which is a more depleted water. It's not quite a surprise because we don't expect that dry season rainfall is large enough to feed plants in river discharge, groundwater, but it's a bit curious to see in a graphic this behavior. We still need to make some statistical analysis. We still need to check really the values of the rainfall isotopes, but it's a first overview of all these results together. And then I also put this in a dual space. And then we see here there is a very similar space here in the dual space where it's we found the groundwater, the river water, and then the plant water and the tap water. It looks a bit more evaporated. So if we have water from the rainfall period for plants in urban areas, sometimes in the dry period, we also have other water sources that makes this behavior happens, or this deviation from the global meteorological and local meteorological water line. Oh, these are very preliminary results. It's just an example in how we are doing and how we are analyzing these data. And then I'm a bit lost in the time because we wait sometimes in the beginning, but in this meantime, when we are looking for the answers for which are the source of waters that plants transpire, there is a competition between plant transpiration and groundwater recharge. In this way, we are still looking for the answer. We are still in the way of this research, but in this way, sometimes the way important is a bit more important than the goal. We also have a lot of researches and studies, such as Santos et al., the PhD Kleber Assis Santos, and he compared in São Francisco Xavier the signal of the rainfall that comes from the Amazonia, called sacas, and in the other rainfall. So he found that the rainfall that comes from Amazonia is more depleted than the other rainfall sources. And in his thesis, Kleber also analyzed the rainfall in that transect that I showed before, between São Francisco Xavier, São José dos Campos, or Serra da Mantiqueira Mountain and Serra do Mar Mountain. And then he analyzed the values of rainfall in all these four areas. And he compared, and he found very interesting results in terms of similarity, or where we found a decrease in the axis, or the axis decrease in the lower regions here in São José dos Campos and the Piscingaba nucleus. And it's published already. You can check. And then we also have the thesis from Victoria Morim, and then she used the rainfall data collected by Kleber Assis, and then she split this in terms of the precipitating events, so cold fronts, isolated rainfall, the convergence zona de convergence zone, and then the zacas. And then she found very specific signals for these different meteorological events. And then she compared, okay, if I have for the years 2021, 2029 to 2021, well, if I compute the amount of rainfall coming from cold fronts, isolated precipitation, mesoscale systems, and ZACAs, we will find this. And then if you use this distribution for the isotopic signal to compute the events that happen in this period, we will find this. So there is a very good similarity apart from these cold fronts that are different from the values computed based on CPTEC or the values computed from isotopic signal. But his published thesis, you can also have access to these results. And then the idea is, well, the idea is to see, well, if the rainfall that comes from, if the rainfall that feeds the trees or feeds the urban or the groundwater comes from Amazonia, we should have a protection effort to protect Amazonia. Or if these events are distributed, so we need to a bit understand where the source of water and how can we maintain our hydrological cycle, our amount of rainfall in São José dos Campos and Paraíba do Sul Basin in order to continue our economic activities. I'm almost finished. And Victoria Amorim also compared the variation of the signal during a typical event of cold front, mesoscale system, and ZACAs. And then she also measured the variation during an event. It was important for us to better understand if such water is in fact from mesoscale event or for cold front. And this is the thesis of Cássia Almeida. She's ongoing and analyzing the tap water. These are the very, very first results. And then finally, the study from Luciana Ferrer, she's going to present right now. And at the end, I would like to thank this very nice and compromised team. And then, and without them, nothing that I showed you, it was possible. So thank you. I'm happy to answer questions. Can you hear me?
Yes. Thank you, Laura, for the nice talk. We have time for one short question. So, regarding your research, what is the main lesson you have looking for these different compartments of the hydrological cycle?
The main lesson?
Yes.
In terms of results, or?
Yes, in terms of perspective and something you and your research group have observed on that.
I think not in terms of the results, but in terms of our ability to have these results. I think when you choose to work with isotopic analysis, it's important to have a very huge team or the association of the community or the association of local people, because we need a very large number of samples. And then it's a bit easy to collect, but not easy to spread in scale and in time. So what I feel is that I need a lot of people working together and to have a large number of samples, and in order to compare and have a broad overview of the scale, basing or hydrological basing or municipality. So this is my main concern when I choose to work with isotopes.
I have the same feeling about that. So we need to involve people to collect samples and have a very large collaboration network. So I think this workshop, we are planning for the second workshop on laser application for the next year or 2 years. Thank you, Laura, for your talk.
Thank you.
For the presentation, and Lucian is here, so we will have time to discuss about results or about something. Thank you.
I will leave here the. Thank you. I will quit now for the teams, or maintain, or I can stay here. I don't know.
It's up to you.
Okay. I don't want to disturb the presentation.
Oh, we will have a coffee break now. If you have time, you can join us.
Thank you.
We took the plane in São José and come to the plant. But if you want to stay connected on Meet, okay, no problem. If you want to move for YouTube also, it's fine for me.
Okay, I will see you in YouTube.
Okay.
Bye-bye. Thank you.
So I would like to invite Rafaela Rodrigues Gomes. She is a geographer and master student here from my group. She's working on the project climatic controls on the isotopic variability of rainfall in the Central Amazon in partnership with the National Institute for Amazonia Research, INPA, and the University of Texas at Arlington. Also, I would like to invite, I don't know if we invite everyone to come here or, and then, no, I will. Yeah. Luciana Ferrer from INPE. She is a geological engineer with degree in geology from the University of São Paulo. So you get your title in, you ask for MEA for this title, okay. A master in mineral resources and hydrogeology and a PhD in Earth System Science from the National Institute for Space Research, INPE. She also holds a specialization in occupational safety engineering from USP. Her experience spans geoscience and environmental science. She is doing some work on mercury hydrogeochemistry, hydrogeology, waste reuse, geodiversity ecosystem service, isotopes, and the recent time, the Anthropocene. She has taught the technical and higher education program and served as a technical advisor and manager in the federal public sector. I would like also to invite Master Isadora Kuhn. She is a geologist and from the URGS, Universidade Federal of Rio Grande do Sul, where she get her master. She is currently pursuing she is a PhD candidate, I guess, almost there. In water resource and environmental sanitation at also at the same university, focusing on southern sector of the Guarani aquifer system, using time series analysis and isotopic tools. Since 2014, she has been a geoscience researcher at the Geological Survey of Brazil, where she coordinates the regional groundwater monitoring network in the state of Rio Grande do Sul and Santa Catarina. Her expertise includes hydrogeology and isotopic geochemistry. And at least Master in Science, Natalia Souza Arruda. She is also a geologist, graduated from the Federal University of Mato Grosso, and she holds a master's degree in urban engineering with focus on environmental geotechnics and hydrogeology from UFSCar in São Carlos. Her research has focused on engineering geology applied to risk areas mapping, land use management, and the quality and vulnerability of pores in unconfined aquifers. Actually, she's doing his PhD here in our group, doing some research in the two northeastern aquifers in a semi-arid region. So, thank you. Rafa?
Is that okay if I sit here? I need the pointer. First of all, I'm honored to be presenting here today at an event that everyone has doctor or master before their names, and mine is still Rafaela Gomes, but I will get there. Today we'll be sharing some preliminary results from my master project about how stable isotopes could help us to understand atmospheric controls in rain in Central Amazon. I'm developing this project at the Laboratory of Water Resources and Environmental Isotopes. with funding from FAPESP. And recently, I developed part of these results at the University of Texas at Arlington. Okay, so this study is located in the north region of Brazil, in the Amazonas state. And the rain samples are collected by the National Research Institute, National Research Amazon Institute, known as INPA. So why is this study conducting in Amazon? The Amazon plays a key role in South America climate, acting as a major source of moisture for rainfall through the atmospheric rivers. However, the isotopic studies on rainfall in the Brazilian Amazon were interrupted in the 19th, leaving gaps in understanding its relationship with large-scale and local atmospheric controls. Moreover, the Amazon, home to one of the largest forests tropical in the world, presents challenges as the source of moisture comes from the ocean, the Atlantic Ocean, and also from the evapotranspiration. The evapotranspiration contributes about 30% of the local vapor in Amazon. So this mix of sources results in a mixed isotopic signal in the rain. So in Amazon, we really need to have a detailed, spatial, and temporal analysis when we are talking about isotopes, rain isotopes. Regarding the large-scale atmospheric controls that contribute with precipitation in Amazon, the movement of the Intertropical Convergence Zone, the ITCC, north and south, results in a different spatial precipitation in Amazon. And ITCC also interact with high pressure zones, mainly the South Atlantic subtropical high SASH. So SASH here is represented by number 1, and ITCC is represented by number 6. So SASH change in position and change in intensity. And these two systems, ITCC and SASH, they interact each other, and they result in precipitation in Amazon, and also the convective systems, the local convective systems. So to answer this challenge question, this research search to answer what is the rainfall isotopic variability associated with local and large-scale atmospheric controls in central Amazon. In search of these answers, the meteorological and isotopic data were collected between March 2023 and February 2024, including rainfall and temperature for calculating ET and aridity index. And the historical data from GENIP network were also obtained to compare with the current data. ERA5 reanalysis was used to analyze the large-scale atmospheric synoptics controls, while the air mass backward trajectories related to the precipitation events was generated by high-speed model. And the isotopic samples were analyzed at São Paulo State University, campus Botucatu, and also at the University of Texas at Arlington. And the data were visualized and processed in these softwares here. Okay, with that, our results so far. I will present our results so far. Here in the origin of the trajectories. So pink is north of the equator line, and purple is south of the equator line. Here we observed that during March, April, and May, we have more north trajectories coming from the north, um, and more depleted isotopic signal. In late May, there is a shift to more south trajectories, accompanied by a more enriched and after stabilization here until October. And starting in October, we start to have a slight depletion in October, and followed by mix of sources and isotopic signal. In historical data from Geneve network, we also saw some sazonal pattern like we have in our current data. Regarding the aridity index, the orange squares here are the aridity index, and the black circles are the oxygen 18. So we observed that during June, from June to October, ET exceeds precipitation, and it results in a more enriched isotopic signal. So it's important to consider that during this dry season in Amazon, the evapotranspiration contributes with the enrichment isotopic signal. And here we have three maps. The main map shows the trajectories, the backward air mass trajectories, and their clusters. The map with a blue band represents the movement of the ETZC, and the outer map represents the position and intensity of the high pressure zone SASH. So we observed that during March, April, May, the wettest quarter, we have more north trajectories like we saw in the previous figures. At the same time that ETZC is further south and the SASH is farther from the continent. So these wettest conditions results in a more depleted isotopic signal with this dynamic here. In June, July, and August, we observed that the ITZC is further north, while the SASH is moves close to the continent, and it's more strong. It results more south trajectories during this driest quarter, and it contributes with more enriched isotopic signal. And in this quarter, mainly we have the contribution of the evapotranspiration too. So until now, our final considerations is that the isotopic variability of precipitation reflects change in moisture sources that generate precipitation in the Amazon, which is associated with the influence of atmospheric forces and moisture transport from large-scale systems and evapotranspiration in ET. And further north, under extreme dry conditions, the more enriched isotopic values also reflect the crucial role of ET and sustained precipitation in Central Amazon. So, thank you very much.
start.
Okay, well, okay. And we collected, we mining data from the Temadem pluviometers. We analyzed the isotopic composition of the waters in the delta 18 oxygen and delta deuterium, and in our equipment carro, and we have the L2130 in our lab. The objective of our study is to study groundwater recharge in São José dos Campos. This is the study area in the municipality of São José dos Campos, within the Paraíba do Sul River, and the samples collection, or the points are located in the suburban and periurban areas where I saw, and we separate by western, southwestern, southern, and eastern, and most of the samples was collected in eastern and southern, because the last two vectors, these two regions are the vector of densification, urban densification, and occupation, and consequently more demand for water. We highlight too the rainfall points of collection of rainfall points collection in here in distance, in kilometers, in their elevations. Here is the rainfall from São José dos Campos, and the upper basin in São Francisco Xavier. That's the district of São José dos Campos, in Serra da Mantiqueira, and oh my God, this transition is in Núcleo Santa Virgínia, upper basin, Serra do Mar. We highlighted too the geology of the area, where we are in the Taubaté sedimentary basin, where the sediments are originated from rocks of the Precambrian basement, and we have two formations: the Pintamonhangaba Reserve Formation from the Paleogene, 66 to 23 million years, and the Pindamonhangaba Formation of the Neogene, 23 to 2.6 million years. And we highlight to the alluvial deposits from Quaternary. Most of the points were collected in the Pindamonhangaba and the Reserve Formation, but the alluvial deposits, the springs are, some important springs are in this place. We highlight to the other classification by the ideological domains, the alluvium and the Taubaté basin type. Like I said the study area were in the periurban region of São José dos Campos. And we showed some results. The isotope signatures were of the samples collected, all the rainfall, deep well, groundwater from deep wells, and springs were plotted in the dual space in two seasons: rainy or wet season and dry season. We show to the local water meteorical lines of the study area, São José dos Campos, we study the recharge, and we show to the Serra da Mantiqueira, upper basin Serra da Mantiqueira, São Francisco Xavier, and upper basin Serra do Mar, Núcleo Santa Virgínia. And we show to the isotopic lines of the groundwater, of deep wells and springs. Springs in yellow, deep wells in purple, and local water, São José blue, São Francisco Xavier in red, and Núcleo Santa Virgínia in green. The results showed that none of groundwater, whether from deep wells or springs, intercepted the local water meteoric line from there, São José dos Campos, or São Francisco, or Núcleo Santa Virginia, or Núcleo Santa Virginia during the dry period. Okay? We bring to the main of the delta 18 oxygen and delta deuterium for all the water collected, and the main separated the wet and dry season, and we bring to the weighted bin of the rainfall for event, and we also to project on the isotope signatures by box plot or box diagram, and the results reinforce that significant groundwater recharge occurs predominantly during the rainy season, the wet, because the isotopic conditions of precipitation are more consistent with the signs observed in the groundwater. At the moment, we are developing our analytical model we are proposing, and the analytical model proposed a Dixon equation that considers the sum of the isotopal signal of the groundwater from the deep wells plus the weighting of the amount of the rainfall and the isotopal signal of the São Francisco, São José, and Serra do Mar, Santa Virginia, that will result in the isotopal signal of the discharge in the springs. In other words, delta 18 oxygen US is the isotope signal of the springs in the discharge. Delta 18 oxygen G is the isotope signal of the groundwater from the deep wells. Delta 18 oxygen R is the isotope signal of the rainfall in São Francisco, São José dos Campos, and Santa Virginia, respectively, and the omega is the weighting factor for the amount of rainfall in São Francisco, São José, and Santa Virginia, respectively. The weighting factor is the amount of rainfall that contributes to charge by subbasin in São Francisco, São José, or Santa Virginia. It is adjusted in each subbasin until the value of the isotope predicted for precipitation corresponding to the average value of the isotope measured in groundwater at the source. It's assuming that the higher the elevation, greater the amount of precipitation. On each omega values went from 0 to 1. Is it? Thank you very much.
So I would like to invite. What do you mean? Você mesmo.
Morning. First of all, thank you for Didier and the group here for promoting this event and inviting myself for this presentation. I will present a study that's part of my PhD thesis that I like to finish in the following months. It's part of the internship I did at the IAEA. I stayed there for a year working with Lucia Ortega. That's one of the co-authors of this paper, this work. It's not published yet, but it's about understanding and quantification of groundwater mixtures at the southern compartment of the Guarani aquifer system. So the Guarani aquifer system is a large porous aquifer, and it's spans for different countries in South America. It's very important both for water supply and agricultural uses, industry. So around 90% of its surface area is confined by the volcanic layer of the Serra Geral group, and it's a very complex and heterogeneous system. The southern compartment has even more stratigraphic heterogeneity than the northern areas, and it's highly affected by geological fault systems. And due to extreme weather events and change on cropping, many new boreholes have been drilled, and deep wells are widely using side water for pilot systems, irrigation. So the objective of this work was to characterize the isotopic and hydrochemical characteristics of groundwater on the southern compartment and quantify these vertical mixing proportions. So it's this cross section shows the importance of the outcrop areas that are very restricted in area compared with the whole system. So we used stable isotopes and chemical data from both Brazil side and Argentinian side to characterize the Guarani groundwaters. And we also used data from the database from Vives and from the Guarani project. And we applied an in-member mixing analysis by a code that was developed by the University of Barcelona group. And the sequence of the in-member mixing analysis is like first we make an evaluation, identification of the main processes, and the identification of the potential sources or end members for the mixing, and the selection of the tracers to be used, a principal component analysis to identify the end members and the mixture patterns, and then the quantification of the contribution of each end member. So we have here is plotted on gray the Brazilian data, and on the black the data from Argentina. We see that in Argentina we have a clear water evolution from more calcium carbonate to sodium carbonate, while in Brazil we have a wider distribution on groundwater types. While these sodium chloride sulfide waters are from deep boreholes from more than 1,000 meters that are probably pumping from pre-salt waters. So the isotopic signatures of the groundwater, they have not very big differences on average from the deuterium and oxygen. Here is deuterium, here is oxygen, from between the outcrop areas, the moderated confined areas in Brazil, and the deep confined areas in Argentina that are the yellow, green, and blue in this order, while this red dot is the precise boreholes. And we see here in the plot from the comparing with the local meteoric line from Argentina and from Corrientes in Argentina and Porto Alegre in Brazil. We have a more close signature to Porto Alegre, but it's not very clear. It needs to be better evaluated. But what we see is that between the deep confined areas in Argentina and the moderate confined areas in Brazil, they are quite there is a quite wide distribution. But we see there is a separate cluster here, more depleted waters, while here we have the precipitation in the from Porto Alegre. So the end member identification, we used 10 tracers, including physical chemical data, data and the oxygen 18. And we identified 4 eigenvectors that reveals 85% of the variance of the system. So we identified that the Guarani waters can be classified in kind of 2 different phases there. We have a more evolved phase that's like more influenced from the carbonate and have some influence of calcium, more influence of calcium, while the recharge are very negative correlated with the sulfate and sodium. And we could also identify very clearly the pre-sag groundwaters and also the recharge that is waters that are reaching the Guarani from the basalt layer. So comparing the isotopic data with the data from Ortega 2020, we see that the N members identified by her in the Argentinian sector fits quite well with the description of our boreholes in the Brazilian side. And she identified this separate cluster, more depleted cluster, as the SAG N member there in Argentina. And when we plotted our data from Brazil, we could identify that this N member here is one of these dots, while this N member that would be in this case, this one, the more evolved water, while this one is very close to the weighted precipitation isotopic signatures. That's from a monitoring network from the National Monitoring Network. While this point here is this deep borehole from pre-sag water that's plotted exactly here with the N member identified by the second. So the quantification of the contribution of each N member shows that around 30% of recharge that reach the sag waters are related to the infiltration through the confining layer, the volcanic confining layer. And around 2% of the pre-sag waters are considerably changing chemistry on wells that are pumping exclusively from Guarani. Also, the mixing proportions, they are highly influenced by the geological structure and degree of confinement. So the distribution of of the mixing proportion shows that, for example, we have an increase on the confinement degree from the east to west here. So we have more influence on pre-sag waters in these more confinement points. And this is, I will be quick but this is the validation of the model. So we see that we have a very good agreement between the expected and the calculated composition of each N member. And we see that a very small amount of pre-sag water can change considerably the chemistry of the Guarani waters in centrally. And I think this might be discussed on how much the unsustainable use of Guarani waters can enhance the uplift of these old groundwaters. And we see that the set of tracers selected for the N member mixing analysis were useful for the identification. And for future studies, we intend to use the parameters model with tracer ages to better constrain these mixture patterns.
please. This is Natalia.
Good morning. My name is Natalia. I'm part of this work. I'm sorry for that. I don't put other authors too, but yes, I just represent this work. So, I will start this presentation during this question: what's the isotope centers review in semi-arid regions, and how we can see it's not so different when we see we can see that in other areas too. But nowadays, semi-arid region are considered the hotspot area when we're discussing about climate change. So back to the point is evaporation can be high and can happens high evaporation. We can find unspent groundwater and also salinization is common in semi-arid regions. And they can be key tool for aquifer management and the phytoclimate system. So focus on saline states. We have great management with your resources, hydrological resources promoted by COGER, that is a company of a management company of this saline state. And saline state have asphalts, have river, have transposition of San Francisco. So they are doing a great job about the management. When we see saline state 2, we can see the big variation of precipitation. This graph shows the first year of this program of monitoring and the second year. You can see on this near this area the sample of this amount of rain. We can see a big variation of the precipitation. And besides that, it's huge, produce a lot fruit and for exportation. So in this region we have this challenge, and this kind of a program of monitoring is important. So to understand the groundwater flow conditions and in the Potiguar Basin and the Araripe Basin, we promote this starting this isotope monitoring program for the middle and low aquifers of the Araripe Basin and the Jandaíra and the aquifers of the Potiguar Basin. This is the front cover of the monthly report we provided to COGER. And the methodology is monthly sampling of 10 wells from Potiguar Basin and 30 wells from sedimentary Araripe Basin. The monthly sampling is the stable isotope, and periodically sampling with another traces like tritium and isotopes of carbon. The first results in just we put 2 years of this. So I will present 2 years of monitoring, and related to Potiguar Basin, you can see the Astu aquifer is it's different, have a different signature than the Jandaíra aquifer in red. And in box plot you can see that, but related and confined ASU aquifer, you don't see big differences in these areas. And here I put the first sample, rain sample we collected. I think it's October, and they have signature how we expect. When we relate to the stable isotope with the percent modern of carbon, we can see that is they are low concentration of the carbon modern and a big variation of the oxygen, 18 oxygen. So when you see the distribution of the wells and with the potassium level, we see that the recharge can start. It's bigger here in this region and at outer area of ASU aquifer than here in more north of the Isotope area. In Araripe Basin, the classification of the aquifer is a challenge, a big challenge, and we can see the some points related to the classification of the aquifers, but you see that as we have the relation of oxygen 18 and carbon model. So we have to do this kind of interpretation in Araripe Basin because we know there is some points of mixture, so we understand that there is more duplicate signatures compared with enrichment signatures, and these mixtures have some correlation of the you can see the two about the modern carbon. So this discussion first in Araripe, in Potiguar Basin, we analyze with the oxygen 18 with the precipitation, and we can see we can see the recharge occurring in this area, and when we see when we analyze the first year and the second year, you see that higher evaporation more than the first year, and we think it's because of the more recharge occurring, so the evaporation from rain we can observe in the second graph. So this is the area of this sampling, and all these areas have contribution of the recharge. And when we see when we discussion about the Araripe Basin, we can see through the recharge area and not so differences in this evaporation, and in Araripe Basin you can see tendency of upper the sanitary stay upper of the global meteoric. So the final considerations we can see about these topics, but I want to highlight it to
things about the challenges we can see when we work with like a particular basin, one that is transborderly aquifer. So the challenge is a big challenge when we analyze just 10 wells of the big sedimentary basin. And related to the Arabic basin, we have the challenge about the structures you can observe in this kind of tools. So we're discussing now about how we can improve this results, this analysis, and you understand that this program of monitoring can provide to us further information about the hydrogeological flow. I thank you.
So I would like to invite all presenters for the table to have a short discussion. And something that I would like to mention, basically, is a woman doing isotopic research. This is amazing thing.
Yeah, was this a coincidence or was it something that you really looked at?
No, it's not a coincidence.
This is very remarkable.
Yeah, sure.
We all know how geology universities are very chauvinistic.
Yeah.
And
It
so,
is.
by the fact that we have four talented young women doing this research, this is a very important point.
3 geologists and 1 geologist. So this is an important point, and I would like to congratulate with you for doing that. If someone has question, please.
So, one question to Rafael. Yes, congratulations for everybody. Very, very nice studies covering different parts of the country. So this is also remarkable. In the Geological Survey of Brazil, we kind of keep maintaining that GENIP network for rain, isotopes in rain in Brazil. So this is about to be launched, and we can discuss it further. How we can add some other other devices from other research institutions inside this network. But we do have new data in Amazonas, in Manaus, since we have the GENIP working since 2018, and also Porto Velho, Belém, Marabá, Santarém. So if you believe or if you think that that monthly isotope signature for that specific time that you covered in your research would be helpful, just let us know. That might help. So this is just a comment. For Luciana, I would be, very curious to see and to understand from you if those 2 rain devices that you have installed in São José dos Campos and São Francisco Xavier, are they about to be on a long-term working and collecting monthly based rain, or is just for the research period? So just keep in mind this question. And yeah, no, that's it. Rafael and Isadora, no question.
I have a question for Isabella. I'd like to know how much the mixing inside the water can interfere in the quality of water that are pumped or the building.
Yeah, so what we see from the results uh, that most of waters in this more recharge zone, the outcrop area in the Brazilian side, they are mostly calcium bicarbonate waters, very like fresh waters with very low electrical conductivity. But some, even in very unconfined conditions, they have some more sulfide content or sodium content. So it might reflect the contribution of these older waters. So it's relevant, the change on water under composition.
Did you identify other elements apart from saying waters? Did you were able to practically find any other elements that could be in the deep water that is now in the shallow waters?
Generally, these three side waters, they contribute with fluoride content and also can some chloride, but the chloride is still a discussion. It really came from this older aquifers or they are mostly from surface contamination. But I think the most prominent and more studied element that's being added to the side waters through these mixing mechanisms is the fluoride.
This is the my question. The time scale collection because I have one season just rainy and dry season, and because these two we are constructed our mixing model, analytical model of facial mixing because I thought we need more data, yeah, or we need more temporal data. Then we had only one season, dry rain.
It will be useful, the data. Let's talk after. Thank you, Herman. Mario?
Sienna, are you taking samples on monthly or daily basis?
I think samples to one period of campaign. One side campaign in dry and one side campaign in.
No. My question is the frequency. If you take one sample per day, or you collect the samples. Yeah, rainfall. Yeah.
Yes, by event.
By event.
Yes, by event. When
you took a sample.
Yes.
And so I remember that looking for the previous study. My question is if you are looking the origin of this precipitation because you are close to the sea, or if in this spot you have some influence from the atmospheric rivers or something like that.
I thought about the orogenic effect, but the best question is the distance between São José dos Campos and Santa Virginia and São Francisco Xavier, because São Francisco is near, approximately near to São José dos Campos, but Look Santa Virginia isn't it so far, and but it isn't. Yeah, there are more rain in Santa Virginia than in São Francisco Xavier because this the mixing model is my as I think about a lot.
And I have another question for you. No, it's not a difficult question. It's something that I observe it.
Because I have a lot of doubts too.
Okay, okay. We always have. This is part of our job. This is good because we have new questions to answer. I was looking when Laura presented the results, and some very depleted values for precipitation, about more than minus 13 for oxygen 18 is not very common. The most depleted value we observed here in Rio Claro or in tropical zones is about minus 15, 18 is very, very uncommon. But when I was looking this box plot, I pay attention on that. Do you have any explanation for that, or you?
I didn't check in.
With Laura, results from Laura is about the jet falls, leaves, and not very ground water. I don't know if it is, but in my case, I didn't analyze yet.
Someone has another question?
Thank you for your presentation. My question is, Rafaela, in high speed, you need a different altitude for the modulation, see, for the simulation. How many do you altitude in the simulation? Understand my question?
Sorry, how many?
Altitude.
Altitude.
State of the
Oh, okay, it's
start of the trajectory.
80, 58 PA.
What is the criterion for selection?
Because we selected some papers that shows that this is the 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 area in the atmosphere that the trade winds flows. So we selected these high because of this.
So can you make a spoiler on the tracers that you and we are about to use on that same wells that you are doing this mixture model?
We are going. Well, Roberto is teasing because we are super happy because we are going to acquire or receive a mini ready. That's a portable mass spectrometer that measures double gas on site. So I think it will be super interesting, and we're very excited to both combine these on-site gas data with the age data we already have in the area, but also to evaluate how these gas are moving from the deeper aquifers to the surface, and how it's affected by the mixing.
So I have one question for you. I was really interested and really happy to see that your mixing model indicates that at least 80% of the water in the shallow zone of the Guarani aquifer drains the basalts. So we have the same results using other tracers, using strontium isotopes. Carolina did a very good job. She's not here, but it should be mentioned. That shows exactly the same. Do you think on using other tracer to identify this kind of process, or only with the classical hydrochemical parameters you are able to say, okay, water, the recharge is from the basalts? And I don't know if you have, I have one question for Natalia. Is that what do you think, or what is do you think that is the reason for the very good correlation between C14 and oxygen 18 in Ararimpe Basin? So we have more depleted waters, old groundwater with more depleted, and young groundwaters more enriched. Instead of in the Potiguar Basin, you have low carbon-14 contents, and you have this large variation on isotope composition.
Thank you for your question, DJ. It's very interesting because it comes also in the direction of the discussion we already had on the extension of the recharge, right, in this area. So it's an interesting result. But honestly, I think I still need to better evaluate the borehole profile, each borehole profile and the contribution, because I think this can also influence the analysis, right? Because if it's a shallower borehole or deeper, see, I mean, I want to evaluate it better, but I'm also very excited to use this kind of device that we're going to receive, for example, to do more constant monitoring from recharge process, for example. So I think it can be useful to have real-time analysis on rain events, for example, also using the radon, the RAD8 we are going to receive as well. I think it can be interesting. And, well, if you have any suggestions, please.
Can I add something, Isabel?
Yeah.
I think this is one of the few data sets in Brazil where we can get carbon-14, novel gases, tritium, hydrochemistry, radon, plus, yes, now, later on, novel gas with a portable equipment, and also monitoring, daily monitoring network. So it's a kind of playground that probably a lot of people are going to work with this data, and we can benefit a lot and try to get some conclusions to try to expand this to other areas of the Guarani. So I think it's a very clever idea from the Geological Survey of Brazil to have this kind of effort.
I'd also like to add, I just remember to mention to Didier that we are enrolled in a CRP now for numerical modeling of this area. So let's see what the results from the numerical modeling that I think also can add some more information to this discussion.
So when you see the differences of the area with the outcrop areas more so of the particular days, we can see the high percent of carbon, high carbon percent of carbon monoxide. So, but we, in direction of the ocean, we see this the concentration of carbon monoxide is low. I believe that it's because we have long distance flow can mixture with this paleo waters in this aquifer. So we have semi-confined situation observed in this in this in this aquifer, in Yasu aquifer, and in the outcrop area, these two outcrop area is have differences in their flow. So I believe that is that we don't have the although is the outcrop area or confined area, we will have to see how in the local this recharge is occurring.
Thank you. Any questions? So, Laura answered the reason that we have a large span because it's a event-based something, and I would like to thank Laura for the answer because the results pay me attention. If we don't have any question, I think we can close the session. Probably we will change our schedule for this afternoon because Professor Vladimir has a problem, a healthy problem, and he is not able to come, and we will change some talks. Thank you for everyone. Yes, we are expecting to return 13, yeah, 1:13 p.m. But yeah, we won't have one talk. I will propose to return 2:00. Yeah, it's fine.
Very important question.
Yeah.
This very nice food called Capitão, where we can get it?
If you pay, I can drive.
No, is there a plan where we can go for lunch? Or because
Yeah, it's a good
I have
place.
this very good food in my mind.
Yeah, okay. If you want or you like meat,